Greetings, I'm Squared, and we're going to talk about special right triangles. So there are two kinds of triangles, right triangles, that we call special right triangles. And those are, the first one is a triangle that has a 45, 45, and a 90 degree angles within the triangle. And the other one are if a triangle has 30, 60, and 90 degrees. So if you see a triangle where you know it's an isosceles right triangle, that would be this one. Or if you have a 30, 60, 90, meaning these are the angles of the triangle. They have a special relationship between the sides. So today we are going to talk about those two and how, if you have one side, you can find all the others. So here are our two triangles. You definitely want to write this down, and you definitely want to memorize it because you do not get any of this on your quiz or tests. So that's going to take a little bit of getting used to. So in an isosceles right triangle, that means that two angles are 45. Remember, if it's an isosceles triangle, if the angles are congruent, then these sides are congruent. That's why they're each x. The relationship is that if you multiply the leg by the square root of 2, you get the hypotenuse. But we're going to use similar triangles because what we know is that if there are three angles of one triangle congruent to three angles of another triangle, that the triangles are automatically similar, which means that their sides are proportional. So anytime we are going to use, anytime we need to find a side, a leg, or a hypotenuse, then we're going to use this proportion, 1/2. We know that if the leg is 1, that all we have to do is multiply by radical 2 to find the hypotenuse. And we're going to use proportions to do this. Some of you might use the shortcut where you say, oh, that's 3, then that's 3 square roots of 2. And that's fine. But to start off, I'm going to use the radical, this 1/radical 2 ratio. So in a 30, 60, 90 triangle, it's important that you know what each of these are. If this is 30, then remember, this is the smallest angle, so this is the shortest side, because the smallest angle is always opposite the shortest side. This would be the longer leg, and I could have said leg there too. And then this would be the hypotenuse because it's a right triangle. So it's important that every time you see a triangle, you know what the longer leg is, the shorter leg, and the hypotenuse so that you can set up these proportions. So the proportion between the hypotenuse and the shortest leg is a 2-to-1 ratio. That means if you knew this was 3, the short leg, then you know hypotenuse is twice that big, so it would be 6. Between the long leg and the short leg, there's a square root of 3/1 ratio. So if you knew this was 3, then this would be 3 square roots of 3. And between the long leg and the hypotenuse, there's a square root of 3:2 ratio. So we're going to use those ratios to solve those problems. So if you haven't written those down, pause, take the time to write them down, because we're going to use them to solve these other triangles. So the first thing I do is realize that there are only two kinds of special triangles, special right triangles, 45, 45, 90, 30, 60, 90. So in each problem I have to say, hey, what kind of triangle is that? Well, since I see a 60 here, I know this is a 30, 60, 90. So which part do I have? This is the hypotenuse, this is the short leg, this is the long leg. I need to know so I can set up my proportion correctly. Because my proportion, since I have a long leg, I have to use one of the ones that had long leg in it. So I'm going to use the one that says long leg over short leg equals square root of 3/1. I'm going to use that proportion. So I say, okay, my long leg proportion ratio is this. So what's the long leg of my triangle that they've given me? It's 15. And what's the short leg? It's y. So I set up this proportion. Long leg to short leg equals long leg to short leg. This is the proportion that is always true for 30, 60, 90 triangles. This is the proportion that is specific to the triangle I'm working with. And then I cross multiply. 1 times 15 is 15. Square root of 3 times y is square root of 3 times y. And all I have to do to get y alone is divide by the square root of 3. Now, let me explain something up here for you, because this is called rationalizing the denominator. So one of the rules that we have to learn or remember from Algebra 1 is that it's not considered simplified, an expression is not considered simplified if there's still a square root in the denominator. To get rid of it, I multiply by the square root of whatever that is. So the square root of 3 times the square root of 3 actually is 3. And then 15 times the square root of 3 is 15 square roots of 3. So now you notice there's no longer a radical in the denominator. But it's still not considered simplified because 3 goes into 15. Sometimes that happens. So I say, how many times does 3 go into 15? 5 times. So my answer is 5 square roots of 3. This would be considered the simplified version of this. So although these are exactly the same, this is considered the simplified version. So that is what I would get for y. Now, once I have the short leg, you need to remember that the short leg hypotenuse ratio was a 1 to 2. That means the hypotenuse is always going to be twice as big as the short leg. So that's why I found the short leg first, because then it's really easy. I just multiply by 2. So x is going to equal 2 times the short leg. So that's 10 square roots of 3. Alrighty, let's try this one. I have the hypotenuse. I don't have the legs. This is a 45, 45, 90. So my ratio from leg to hypotenuse in a 45, 45, 90 triangle is a 1 to square root of 2. So that's my always ratio, and I set that equal to the specific ratio. My leg is x. Oops, sorry, I forgot to do that. And my hypotenuse is 7. So leg to hypotenuse, this is for a 45, 45, 90. So I cross multiply, and I get 7 equals x times the square root of 2. So I divide both sides by the square root of 2. And when I do that, that cancels out. I get x equals 7 over the square root of 2. But remember, that is not considered simplified. So I have to do what's called rationalizing the denominator, which means I have to multiply. Keep in mind that when I multiply by the square root of 2 over the square root of 2, that's actually 1. Anything divided by itself is 1. So I'm not changing the value, I'm just changing how it looks. So when I do that, I get 7 times the square root of 2 over the square root of 2 times the square root of 2, which is just 2. So this is my answer. Okay, try another one. Again, I've got an isosceles right triangle, a 45, 45, 45, 90 triangle. So that ratio was 1 over the square root of 2 equals x over 10. So when I cross multiply, I get x squared to 2 over 10 equals 10. When I divide by the square root of 2, I have to rationalize the denominator, so I multiply by 1, but the 1 I choose is whatever that square root is over itself. So x equals 10 square roots of 2 over 2. And then I see if I can reduce. Yes, I can, because 2 goes into 10 5 times. So my correct answer is 5 square roots of 2. All right. This is a 30, 60, 90. How can I tell? Because that's 90, that's 60. The only option left is 30. So I notice again, I say short leg, hypotenuse, long leg. So I know to go from the long leg, and the ratio between the long leg and the short leg, we just did that one a minute ago, is the square root of 3 over 1. That's the ratio. So I say, okay, long leg is 12, short leg is x, and I know my ratio is radical 3 over 1, and then I cross multiply. So 12 equals x times the square root of 3, and I divide by the square root of 3. I get x equals 12 over the square root of 3. But then again, I've got radicals in the denominator. It's not considered simplified, so to rationalize the denominator, I multiply by the number 1, but I choose square root of 3 over square root of 3, and I get 12 square roots of 3 over 3, but the 3 goes into 12 4 times, so I get 4 square roots of 3. Okay, here we go, 30, 60, 90. Now I have the short leg. Oh, I forgot to find y over here, didn't I? Sorry. Okay, the hypotenuse is just whatever the short leg is times 2. So that's going to be 8 square roots of 3 for y. That was x. Okay, so I have the short leg. So to me, it's really easy to find the hypotenuse. I just double it. So 3 square roots of 3 doubled is 6 square roots of 3. But for this ratio right here, the short leg to the long leg, remember, that ratio is square root of 3 over 1. That's long leg to short leg. So I say long leg, I don't know what that is, to short leg. So x equals, when I multiply these, I get 3 times, and square root of 3 times square root of 3 is just 3, so it's 9. So x is 9. And the hypotenuse was 6 radical 3. Alrighty. Another 30, 60, 90 triangle. So I always say, okay, short leg, long leg, hypotenuse. Hypotenuse is nice, and short leg, if I'm given the short leg or the hypotenuse, it's always nice because that's just a 1 to 2 ratio, so the hypotenuse is always twice as big as the short leg, so I multiply by 2, so I know that's 20. But then this ratio is long leg, remember the short leg is square root of 3 to 1. So I say the square root of 3 over 1 equals the long leg, which they're calling P, over the short leg, which is 10. So P equals 10 square root of 3. And there's nothing to simplify there, so I'm done. Okay, 2 more. So this one is a 45, 45, 90 triangle. So this side's easy because I know it's 8, because it's isosceles. And then the ratio from leg to hypotenuse, remember, is 1 to the square root of 2. And so I say, oh, okay, well, I know the leg, and I need the hypotenuse. So we call it x. So I just get 8 square roots of 2 equals x when I cross multiply. And again, that's simplified, so there's nothing I need to do. That is the answer. Now this one doesn't give you any degrees here, but since that's 90 and these are equal, we know these two are equal, so those would both be 45. So now I know it's a 45, 45. So B has to equal 2 because those are equal. And then how do I find A? Well, I use that ratio again. The ratio is 1 to the square root of 2, and that's leg to hypotenuse. So when I cross multiply, I get A equals 2 square roots of 2. Again, there's no fraction, so and there's nothing perfect, no perfect factors in there. So I am done with that. That is the answer. This takes a little bit of time. You have to memorize those ratios, and the more you practice it, the easier it will get. So make sure you do your homework. Good luck with that. M squared, signing out.